So we can see there are effects here on muscle characteristics and the way in which force is being generated. We perhaps all experience that, particularly in winter months. We're more sluggish to generate force. It's harder. You've probably seen it in sporting situations. Well, let's go a stage further and then go, well, actually, what's the relationship between temperature? Remember, temperature is the response to doing the physical activity, the warm-up, and in this case, metabolism. Well, what do we know? Well, an elevated muscle temperature as a result of warm-up has been proposed to enhance aerobic energy production by accelerating the rate-limiting reactions associated with oxidative phosphorylation. So we know that the enzymatic reactions of both glycolysis and those of the TCA cycle are temperature dependent, as are almost all enzymatic reactions. And what we know is that the rate-limiting enzyme of glycolysis is PFK, phosphofructokinase, and there is quite good evidence to demonstrate that if you raise the muscle temperature, what you end up doing is you end up accelerating the activity of PFK. So in other words, glycolysis operates at a faster rate. If the PFK reaction slows down, then glycolysis slows down. But what becomes very, very interesting is when we read this. There is little effect on resting muscle metabolism when we raise temperature, but increases muscle glycogenolysis, glycolysis, and high-energy phosphate ATP degradation during exercise. And this is quite simply not because you suddenly gained more substrates, but it's quite simply because these are all enzymatically driven processes. So the process of PCR degradation uses the enzyme creatine kinase. The splitting of ATP to generate ADP, phosphate, and therefore energy is enzymatic in the form of ATPase. Glycolysis is a very much an enzymatically driven process, one of which is PFK that we've already referred to. The TCA cycle, enzymatically driven, succinate dehydrogenase as an example, citrate synthase. All of these, because their enzymes have enzymatic processes which are temperature dependent. So if you alter the temperature, you accelerate these reactions. Now, there is the caveat to this, which is if you raise the temperature too much, we get two things. One, we'll get deamination of the enzyme if there's a significant raise in the temperature. But secondly, the notion of what is called the Q10 effect starts to slow. The Q10 effect suggests that if you get a rise in temperature of 1 degree above kind of baseline, you get a 13% increase in the rate of the metabolic reaction. But you can't keep raising the temperature. It's not possible. There is a point where we get to a temperature which is too high and too dangerous for mammalian physiology. So it only holds true over a very, very short window of opportunity. But it does lend itself to understanding why we get accelerated metabolic responses when we have an appropriate warm-up and raise in temperature.